Okay, so we finished the problems on projectile. Do you see the screen?
Yes, doctor.
Okay. Yeah, we still have one last problem in projectile. The track for this racing event was designed so that the riders jump off the slope at 30 degrees from a height of 1 meter. During the race, it was observed that the rider remained in mid-air for 1.5 seconds. Determine the speed at which he was traveling off the slope, the horizontal distance he traveled before striking the ground, and the maximum height he attains. Neglect the size of the bike and joint. So here, if we want to represent it in a small figure, this is our case. What we have here is that they gave us the inclination of the jump, so it's 30 degrees, but they didn't give us the velocity of V0. So V0 is unknown here, we don't know it. But what we know is the total time spent for motion. So when going from A to B, the total time, so T final is given, T final at B, T final is equal to 1.5 seconds, okay? So here, I know T final, and I know if you want the initial and final elevation, because Y initial, this is Y initial, Y0, I know that Y0 is equal to 0, because I start from A, so Y0 is known, and Y final is known because look at Y of B, Y final is equal to -1. So since you know everything about Y, you should think of using Y equation. Okay. So if I use Y equation, it will tell me what? It will tell me that Y final is equal to -5t squared. The only thing that I don't know is V0Y. So I will write plus V0Y. And of course, I replace T by T final. So plus V0Y times T final plus Y0. Okay? So as you can see, Y final, Y0, and T final are known. I replace, I get V0Y. Okay? And once you get V0Y, how to get V0? What is the relation between V0 and V0Y?
V0y is V0 cosine 30.
Sine 30. Why? Because look, this is
Ah,
30. 30 is with the horizontal. Okay. So from the angle, since the angle with the horizontal is 30, then I can write here that V0x is equal to V0 cosine 30. Okay. And V0y, so if I project along y, the y component is cosine 60 or sine 30. Okay. And V0y is equal to V0 sine 30. Okay. So now, if I replace here in this relation, I can get that V0 is simply equal to V0y over sine 30. So first, from this relation, I got the speed, the initial speed V0. Now, they asked me for the maximum height reached. Who will tell me what is the characteristic at the maximum height? What will happen at the maximum height?
Vy
V is
final
0.
Very good. Vy is 0. Pay attention, not the total velocity, because Vx will always be here, since Vx is a constant. Okay? So at any location you will have Vx, but what will be 0 is Vy. So at the maximum height, I can say that Vy at point C is equal to 0, since it's the maximum height, since it corresponds to maximum height, to H max. Okay? And now, how to calculate H max in one step? Who will tell me? I don't want 2 steps, 1 step. I know V initial 0. V0y is known. And V Vy final at t is known, and I want to find displacement. So I can use a relation that is independent of what?
Independent of time.
Very good. I use the relation independent of time, which is the following, that Vy at point C square minus Vy0 minus Vy0 square is equal to 2a, which is minus 2g, minus 2g, which is 10, okay, times what? Times delta y. What is delta y? It's y at point C, y at C, minus y0, okay? So now, from this relation, I will replace in this relation here Vc by Vy at C by 0, and Vy0, I replace it by V0 sine 30. Okay, it's already calculated from here if you want. No need to replace anything. You got it here, V0y. Okay, and for y0 it's 0. So from this relation, the only unknown is y of c. I get y of c. Okay, but please pay attention here. Y of c represent what? Not the height. Look, because you have, this is yc is counted from the x-axis. So this is y of c. If you want to obtain h, what should you do? This is h, the height from the floor. To find the height from the floor, you should
Y
add
of c plus
yes,
1.
exactly. So you will say that h, the height from the floor, is y of c plus 1. And we still only have to find the range r. Okay, the range is very simple because you already calculated the time. The time is given here, t final. So all you have to do is to say that the range r is equal to x final minus x0. It's equal to v0x, which is equal to v0 cosine 30 times t final. So equals to v0 cosine 30 times t final. You replace t final by its value and you are done. Okay? Now, for the maximum height, we said that we do it in one step by reducing the relation independent of time. If you didn't pay attention to use the relation independent of time to find y maximum, you can do it in two steps. So first, what do? You say that Vy is 0. At this point, at C, we said that Vy is 0. From Vy equal to 0, you can get the time, because you know that Vy is equal to minus g times t at point C, okay, plus y0, plus Vy0, plus Vy0, which is already calculated, okay? So you can get the time needed to reach the maximum height, Tc, and once you find Tc, you replace back into the equation of y function of time, y equals minus half gt squared plus v0 yt plus y0. But in this case, you need to do it in two steps. While if you use the relation independent of time, you do it only in one step. Okay? Any question on this? So we are done for today. We meet next time. Bye.
Thank you, doctor. Bye.
Bye.